Hello, we are continuing on through Chapter 7. So if you recall, 7.1 was about ratios, and a ratio is a comparison of two quantities, and a lot of times you put that in fraction form. Well, a proportion is then taking two ratios and setting them equal to each other. So it's an equation. A ratio is an expression. A proportion is an equation that states that two ratios are equal to each other. So usually proportions are written one of two ways. One, you might see it in this form, 2:3 as 4:6, or you might see it in this fraction form, 2/3 equals 4/6, or 2:3 as 4:6. So notice I've said this statement right here. So if you hear someone say 2:3 is 4:6, in other words, they're stating a proportion. They're comparing two quantities to each other. Or two ratios to each other. So notice on my form right here, I have blue numbers and I have black numbers. Yours doesn't have that because we don't print in color. So you might want to highlight those, or you can write them down here as your definitions. So the first term in a proportion and the last one are called the extremes. So here, let me put that in blue. So the first and last are called the extremes. So 2 and 6 are the extremes. And then we have the other two, which are middle two, 3 and 4, are called the means. Now, will we use those vocabulary words in class? Might we state something about the means or the extremes in a problem? Sure. So be familiar with the vocabulary. It may not be used a lot, but when it is used, we anticipate or hope that you would understand what that means. So the extremes are kind of on the outside, right? And the means are on the inside. Okay, now what's true about the means and the extremes? Well, look at them. We have the extremes, which are 2 and 6, the means, which are 3 and 4, and it's actually true that the product of the extremes is equal to the product of the means. So here we go. If we multiply the extremes to each other, 2 times 6, then you're going to get the same answer as if you multiplied the means together, which is 3 and 4. Okay, so let's look at properties of proportions. If I gave you the proportion A is to B as C is to D, then all of these statements are also true, and they could be derived from this right here. So knowing that we have cross multiplication, we can multiply A times D and C times B and make this true, right? If we have A divided by B equals C divided by D, well, if we want to get rid of our denominator, we can multiply each side by D. It cancels here, so we would have dA over B equals C. And if we want to get rid of B on this side, then I would multiply by B on each side to cancel here, and I would have dA equals CB. Or, in other words, the commutative property holds true here for multiplication, so we get this fact that AD equals BC, if given this as the original. So we can do similar things for each one of these examples to show you how this can be rewritten as A over C equals B to D. A is to C as B is to D. So again, if we start with A over B equals C over D, well, if I want to get rid of my C, I can divide each side by C, or multiply by 1 over C to cancel it. Multiply by 1 over C. And so then my new line would be A divided by BC. And then I have 1 over D. And then if I want to get rid of B, I would multiply each side by B. So this would cancel. So I would say A is to C as B is to D. So showing you how I started with my original to get this new one. Again, we can do something similar for this third property. we start with A over B equals C over D. So notice I want to get a B here and an A here. Okay, how am I going to do that? Well, I need to multiply each side by B. Oops, let's change color here. Multiply each side by B, so it cancels here and here. So I have A equals BC divided by D. Get rid of my D. So multiply each side by D. You could be doing this on your own by now, and then we get AD equals BC. Okay, now I want to keep my B on top and my D on top, which means I need to divide each side by A. Cancel. So I get D equals BC divided by A, and then I want to get rid of my C, so I can multiply by 1 over C or divide by C. So these cancel. So I have D over C equals B over A. And if I just reverse that, I would get this up here. Okay, what does this third one say? Instead of going through and showing you how we get it, just look at it in terms of, is it true or not? Or what does it mean? Some people look at that and I'm not sure they understand what that means. So if I started with 2/3 equals 4/6. Right, this is true. 2/3 equals 4/6, because if I reduce 4 and 6 by 2, I'm going to get this fraction. Well, this right here is saying that if I take the denominator and add it to the numerator, so I do 2 plus 3 divided by 3, it should equal 4 plus 6 divided by 6. So 2 plus 3 is 5, that becomes 5/3. 4 plus 6 is 10, that's 10/6. Well, does 10/6 reduce to 5/3? Yes, it does. So you can see that that does work. So what did we do? Again, you're taking the denominator, adding it to the numerator, and those two ratios are still going to equal each other if you do that consistently on both sides. Okay, now let's look at number 2 down here. So if we say A is to B as C is to D as E is to F, continue, 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 then it's going to be true that if we add all these numerators together and if we add all these denominators together, it's going to equal the original ratio of A over B. So again, just choose some numbers and try it. Well, let's do 1/2. If we do 1/2 equals 2/4 equals 3/6, is it true that 1 plus 2 plus 3, right, we add those together, 1 plus 2 plus 3 equals 2 plus 4 plus 6. So 1 plus 2 is 3 plus 3 is 6, 10, 12, and does that reduce to 1/2? Yes, it does. And here's my original AB, and this is my new one. If you're interested about this derivation, then you can ask your teacher about it in class. Okay, so how do we use properties of proportions? Well, here we go. Use the properties of proportions to complete each statement if x is to y as 3 is to 5. So x divided by y equals 3 divided by 5. So using the properties of proportions, number 1, it says, well then 5x equals what? Well, quick cross multiplication, 5x will equal 3y. Okay, now what did we do here? We switched this to make it 5 over y. So 5 is to y, then we're going to have 3 in my numerator and x in my denominator. So 5 is to y as 3 is to x. Okay, how about like this? Letter C is like this fourth example up here, right? So x plus y is to y as 3 plus 5 is to 5. You just add that denominator up here to the numerator, and these should still be equivalent. And then here, if I flip this upside down, I make 5 is to 3, then I'm going to have to flip this one upside down and make y over x. If this is not making sense to you right here, I mean, we applied what we have up here in these 4 examples. But if that doesn't make sense, then pause right now and ask your teacher. Ask your teacher to explain that to you so you can get more practice or you understand what's going on. Otherwise, you can continue. Okay, so here are some word problem examples. So proportions are useful for solving problems involving comparisons. So for example, suppose you were looking at a map and noticed the distance from your house to your friend's house is 2.5 centimeters. This is on a map. And from your house to the movie theater is 1.5 centimeters. So this is my map relationship. And then it says if your friend's house is actually 15 kilometers, so then I have the actual distance. So I have a map distance, and I'm comparing that to the actual distance. So I like to go ahead and set up a ratio to identify the two things that I'm actually trying to compare to each other. That's the map distance to the actual distance. So it says if your friend's house is actually 15 kilometers from your house, what is the actual distance to the movie theater? So you're looking at a map, it's only 2.5 centimeters on the map from your house to your friend's house, 1.5 centimeters from your house to movie theater, but in actuality it's 15 kilometers from your friend's house to your house, so we're trying to figure out the movie theater. So we have the map distance, which is also we have to talk about your friend and the movie theater. Those are the other two factors, right? Your friend, friend's house, and movie theater. So if I say the actual distance, the map distance from my house to my friend's house is 2.5 centimeters. The actual distance from my house to my friend's house is 15 kilometers. Then I would say the map distance from my house to the movie theater is 1.5 centimeters, and the actual distance from my house to the movie theater, we don't know. That's what we're trying to find out. So this set up a proportion which was the map distance relationship to the actual distance relationship. So this right here was the friend's house, and this right here was the movie theater. So then how do you solve? Well, you're going to cross multiply. Oops, so here, sorry about that, I was thinking what's going on. So this should have been kilometers because your movie theater distance is going to be kilometers. So notice my units here are corresponding to what I have. So I have x times 2.5, which is 2.5x. Sorry, I want to put my units here as well. So 2.5 centimeters times x kilometers equals 1.5 centimeters times 15 kilometers. Now, how do I isolate x? I divide by 2.5 centimeters. I divide each side by 2.5 centimeters. Well, notice my units of centimeters are lining up and they're canceling, the units of centimeters are canceling out, not the 1.5 and 25. Sorry about that. So you're going to multiply 1.5 times 15, get 22.5. So x kilometers equals 22.5 kilometers divided by 25. And then you're going to solve that. And you will find that x kilometers is 9 kilometers, therefore x equals 9. So what is the actual distance? The actual distance is 9 kilometers. Sorry, I think there at the end I said divide by 25 instead of 2.5. So sorry, it's 22.5 divided by 2.5, so you get 9, which is 9 kilometers. Okay, anyway, going back to this example, was this the only way we could have set up the proportion? No. We could have done maybe a ratio of friend's house to movie theater. So friend's house to movie theater, except that's not the only two things we have to take into consideration. We also have the map distance and the actual distance, right? So we're going to use the comparison on the map as to the comparison of actual. So friend's house on the map was 2.5 centimeters distance from your house, and to the movie theater it was 1.5 centimeters. In actuality, the distance from your house to your friend's house was 15 kilometers, and this was unknown. So if we multiply the extremes and the means to each other, what do you notice? We show an x here, 2.5 times x equals 1.5 times 15. They are identical products, so therefore you're going to get the same answer even though your original proportion was different. Okay, pause now, try the last two, and come back and check. Okay, final 10 seconds, pause if you need to look at my work, but you should have gotten $2,850 for number 1 and 48 cupcakes for number 2. Bye-bye!